All right, hey everybody. This is the 9-2 Common Core worksheets going through examples 1 through 3. So let's take a look. Our essential question says, how can you use a trend line to make a prediction for the scatter plot? So yesterday in Professor Berger's examples, we talked about those clusters where a group of points are going to lie together, gives information about the data. So here in example 1, it says a scientist gathers information about the eruptions of Old Faithful, a geyser in Yellowstone National Park. She uses the data to create the scatter plot. And then here the graph is telling us the data shows the length of time between the interruptions, or that's the interval in minutes, and how long the eruptions last. So the time between one starts, how long it is, and then more to come. So it says here, describe any clusters that we see. Now first, what's missing is just our title. So make sure we give that a title. I know the information tells us what we're talking about, but it's also good to helpful in terms of the title to have that. All right, so here we have the time in minutes, and it says here that the data shows the length of time between the interruptions. So length of time, and then how long they erupt for. The duration is how long they're going to be. So it says here, describe any clusters we see. Well, I see a cluster around here, and then I also see a cluster around here. So there's a lot of things happening between, I would say, like the average around the 50 interval mark, and then they're lasting around 2 minutes. And then we have a cluster around, I don't know, we say about like the 80 mark, they're lasting around 4 minutes, 80 minutes between each one, lasting 4 minutes. So it says here, describe. So it says describe where any clusters that we see. Okay, so I'm going to type this out. Hopefully this works on here. So I can say there, if I spell it right, are clusters around the 50-minute mark, and also around the, I would say, I guess the 80-minute mark. Okay, 80-minute mark. All right, let's take a look now. Going back to my pen. I don't know how to do that. Here we go. Okay, so part B says here, what do the clusters tell you about the eruptions of this geyser in Yellowstone National Park? Well, we have here that it's for short intervals, for 50-minute intervals, they last around 2 minutes. But then for the longer time between an eruption, they last longer. So we can say there are short times for the, here in our, okay, I don't know where the video stopped. I kept talking. Hopefully we got to the second one there, okay? So the second question, shorter intervals, shorter eruption time. Longer intervals with my second cluster, longer eruption times. So let's take a look at part C. Part C says describe any outliers that you see in the scatter plot. So that's what I have highlighted in the orange right here, is that's an outlier, okay? And maybe I should even just erase it so that we can actually see that it's there. But this point right here is an outlier. So I would say here around, I guess we would say, I don't know, what would you guys say? That's about like 55-ish. Let's do around 55, 55.3, because that's even like 3.5. So I'll just say around 55.3. There appears to be an outlier. So what's happening is it's not falling within a cluster. That's saying around the 55 mark in terms of interval, then the eruption's lasting like 3 minutes versus like the 2 minutes in the first cluster. And it's not long enough for the second cluster. All right, so taking a look down at the bottom here, 1A says, suppose that the geyser erupts for 2.2 minutes after a 75 interval. So I'm just going to erase some of this so I can actually see my graph here. Okay. All right, so now at the it lasts for 2.2 minutes and at the 75 mark. So 75 would be around here, and yeah, my thing's off, and around 2.2, so somewhere around there. Okay, so it says here, would that point lie in one of the clusters? And that's going to be no, because notice this was a outlier as well. So if it's around here, that's not going to lie within either this group here or this group. So we'd say here that. All right, so I guess I figured out when I hit the text, then the video stops. So just explaining 1A, this point, this 55.3, or sorry, no, I'm sorry, the 75 2.2, it would not lie in either cluster because the interval was too long, lasting 2.2 minutes versus like 2 minutes, but yet it's not long enough for that second cluster that we have up here. All right, then 1B says here, suppose that the Geysir erupts after an 80-minute interval, give the range of the possible duration of the Geysir erupting for the point in the scatter plot that would not be considered an outlier. So it's going to fall within the data, okay? All right, so now I'm saying here around the 80 interval mark. So using my pen here, around 80, okay, where would I say that this data is going to lie? Well, I would say that the range is from, let's say, like 3 minutes up to about like 5 minutes. So anything that lies in there would be fit for the 80. So we can say the possible range is 3 to 5 minutes. All right, now let's take a look at the second example. So here it says a scatter plot shows the relationship between the number of chapters and the total number of pages for several books. Draw a trend line and then write an equation for the trend line and describe the meaning of the slope and the y-intercept. All right, so we know for our line, okay, I'm going to create a line here. Looks something like this, starting at the origin in this case. And remember, we're not connecting every single point. This is just a to help us with the grouping, this trend line, okay? All right, so we're drawing our line. And it says here for the first example, it would be easier to write an equation for the line if it goes through 2 points. So it's saying here use 550, okay, so 550, which is on our line. Okay, I'm going to use that point, and then identify another point that our line goes through. And this one we're just going to kind of estimate. So I'm looking at this point up here. That's like 17, I don't know, what would we say, 17, like 170. So I'm just going to use those 2 points here. Okay, 17, 170. Now remember, your 2 points can be different from mine. So this is just an estimate. All right, part B says, what type of association is this? Well, this is definitely in a positive association. As the chapters go on, more pages are getting read. And of course, this is linear. Okay, anything nonlinear would curve or do something different than our straight line. And then it says, what do you expect the slope to be, positive or negative? Well, here, remember our slope is our change in y over change in x. As we're going up here, going to the right, everything's going to be positive. Remember Mr. Slope Guy, we did him too? That line's going up from left to right. All right, so now we're going to use our 2 points to find our slope. So I'm using that 17, 170. So remember the change in y, that's going to be 170 minus their y value, 50, which ends up being 120 when I subtract, over my x value, which is 17, minus the 5, which gives us 12. So this leaves us with 10 for our slope. All right, so now write an equation in slope-intercept form. Remember, m is our slope, b is the y-intercept. Using that 550 and our 1770, we're going to substitute these values in. So in this case here, we have y and x, and they want us to substitute them in now. Okay, so I should actually go back and erase that. Plugging in our x and y, not leaving them there, okay? And we're going to use their point, the 550. So y is 50, x is 5, and then the slope that we just found is 10. So we have 50 is equal to, the 10 times 5 gives me 50 plus b. Subtract the 50 from both sides, and we end up getting 0 here, okay? So the y-intercept ends up being 0. I'm going to subtract 50 from both sides. 50 minus 50 gives us 0. So our equation ends up being y is equal to 10, our slope x, plus 0. Or we could just say y is equal to 10x. So what's the meaning of our slope? Remember, slope represents the change in y over change in x. Well, y is the number of pages, so 10 pages for every x number of chapters. So we're reading, or about, we should say, not reading, but in terms of the books, we have 10 pages per chapter. And then part G says, what's the meaning of the y-intercept? Well, the y-intercept means that if the number of chapters are 0, or the number of pages in the book with 0 chapters. So number of, I was just going to do the x-intercept, but we can write it as the y-intercept too, actually. So here, when I rewrite this, okay, y represents that if there's no chapters, then there's no pages. So no chapters, no pages. Okay. All right, now let's take a look at example 3. So when you use a trend line or its equation to predict a value between the data points that you already know, you interpolate the predicted value. When you make a prediction outside that, it's extrapolate the predicted value. All right, so here in 3A, use the equation in the trend line to predict how many pages would be in the book with 26 chapters. All right, so I like starting with our equation. So we know our equation here is y is going to be 10x. Okay. All right, so now it says, is this prediction an example of interpolate or extrapolate? So using the graph, we didn't have the 26 chapters. So if you go back and flip back to the actual graph, on the graph, it only goes up to about 22 chapters. So here, this is going to be off our graph. So this would be your extrapolate. All right, and then we're going to substitute the number of chapters in for x. So that would be 10 times, if there is a book with 26 chapters, how many pages would we expect that to be? 260. So I predict that 26 chapters would be about 260 pages. Use the equation of the trend line to predict how many pages would be in a book with 14 chapters. So in this one, y is equal to 10x, using the same one. We're taking 10 times that by 14. That's going to be 140. Now for this one, if you take a look back at your graph, sorry I can't go back through there, but the 14 chapters is on our graph. So in this case, this would be a interpolation here, kind of predicting interpolation, what that might be. So in this case, that would be about 140 pages. And it says for 3A, how well do your new points fit on the original data? Well, they fall pretty close. If we go back to your graph for number 2, that 140 is right there. And then 3B says, do you think that the extrapolate or the interpolate is more accurate? Now, in this case, I would say the interpolation is going to be more accurate because it's given the actual data. You could have something that goes like way off the chart for your extrapolate. So it's more accurate with the interpolate because it's on your graph for the predicted value, and that data point are known. There's no guarantee that that trend, like I said, will continue. You can have a point that goes way off in terms of like an outlier type of point. So in this case, it's going to be the interpolation. All right, why don't you guys finish the practice page right below. See you later.